So thanks for inviting me. I don't think I've ever given a keynote presentation before, so this is going to be really fun, at least for one of us. So I'd like to talk a little bit about something that until not too long ago seemed like it shouldn't need to exist, and that's the problem of managing identity in this new era of big data. I just joined Ping a few months ago, and I was really surprised at how small the actual volume of data it takes to manage identity. You've got some ACLs, you've got maybe a database or two, you've got some users. Your databases and your sort of system stores in the identity space are measured in the megabytes to gigabytes. So I never really thought of it as a big data problem until we started seeing more and more things happening in the big data world and the de-silification of information. So it's going to be, this is something that is just now emerging. I don't think 6 months ago this topic would have made any sense for people to think about. But now we're seeing a lot of changes in the industry, and I'd like to talk about that. And feel free to ask questions. So I am the first developer evangelist at Ping Identity, which is really, really fun. Ping is one of the leaders, in my completely biased opinion, of course, we are the leader in identity management, and many of the global Fortune 500 companies run Ping for anything to do with single sign-on identity management, API security, stuff like that. But before that, I actually worked in big data. I was a CEO of a VC-backed database company called Drawn to Scale, and we built what we considered to be the first truly distributed SQL database. And I've always been really fascinated with the concept of identity and what it means to be a something in a world that's completely ephemeral. I read a lot of science fiction because I am a gigantic nerd. And it seems like over the past 3 or 4 years, there's a theme in a lot of the science fiction books I read, things like Rainbow's End by Werner Vignay, Accelerando, and a few others. And in a world that is so incredibly connected that you're defined by who you're connected to and what devices you use, identity becomes more than just how you log in to your system or what your password is. Your online identity or your connected identity is a core part of who you are. And with the era of big data, we're seeing that the repercussions of that are becoming vast. And so it's this intersection. Starting at Ping has been really fun for me because it's been at the intersection of everything I love: identity, distributed systems, and big data. And all these things are coming together really fast now. It's a cool time to be in the industry. So a quick overview, as is necessary in every big data presentation, I have to tell you what big data is because apparently the definition changes according to who the speaker is. So I'll give you mine. Then I'll talk about what is the actual identity issue and why does that matter in the world of big data and in the world of distributed systems. I'll talk a little bit about the timeliness, why this is going on now, and we'll finally wrap up and talk about this concept sketched out called the data DNA. Not really sure if I love the phrase, but we'll stick with it for now. So any data infrastructure you build on the planet can be defined as sort of the intersection of two of these three core concepts. Sort of the most prevalent one is volume. How much data am I storing on disk? How much data am I trying to access? The next one is velocity. How quickly do I need to get answers out of my data? How quickly do I need to store my data? Is this batch processing over hours, or is this retrieving something from memory in nanoseconds? And finally, variety. What different kinds of data sources do I have? Is it all structured data? Is it log structured merge trees? Is it B-star trees? Is it CSV files? Is it unstructured? And any data infrastructure can basically be good at two of these things. The one we're all familiar with, MySQL, it's really good at velocity. It's really fast. It's a real-time system. soft real-time system. And it can handle a decent variety of data. You can have lots of tables, lots of different kinds of storage fields. It's a great Swiss Army knife, as long as you don't try to put too much data into it. Likewise, Hadoop, which is sort of the progenitor of the big data era, it's really good at two things as well. It can handle a large variety of data. Hadoop is just a batch processing system with a distributed file system. So you can do anything you want with it. And it can handle massive amounts of data as well. It's completely distributed. Multi-petabyte installations on Hadoop are fairly common. But it's really slow. Processing data in this distributed Hadoop world is usually relegated to batch processing, or at best, key value storage. And finally, at the intersection of high volume and high velocity is the distributed NoSQL stores. This doesn't mean things like MongoDB or CouchDB. I'm talking more like HBase and Cassandra, Bigtable, Dynamo, things that basically really constrict the variety in which you access data in exchange for making it really easy to scale. So the key problem is that nowadays big data systems seem to need to require all of these. We want to access all the data, petabytes of it. We want to do whatever we want with it, build charts off of it, query it, index it, high variety. And we want to do it all in milliseconds. And that makes life really tricky, because as soon as you make your data storage distributed, by putting it across a bunch of disks or a bunch of networks, that network instantly becomes a bottleneck, and it starts to become more and more expensive. And this even applies in the relational database world. An Oracle installation, it wasn't that long ago that a 1 terabyte Oracle installation running on 8 cores, going from that to a 4 terabyte Oracle installation running on 16 cores may cost you an additional $3 million in licensing and hardware. Scaling is really expensive, especially if you want it to be big and fast. And by big, I mean really big. If we take a look at these two axes, time down here, data volume up here, when sort of the computer era started, most of the data we saw was transactional on mainframes, bank accounts, accounting, stuff like that. But as machines, over time, as machines grow and more connected, PC era, internet era, mobile era, and so on, and down to the machine-to-machine era, basically the amount of volume they produce exponentially increases. And that's because of a network effect. If I, for example, have 5 different APIs, like a Salesforce API, Marketo API, a few other things, there's a lot of value not just extracting data from those APIs, but correlating data across them all. You know, how effective was this marketing campaign against my sales, and so on. And so what we see, and especially in the world of cell phones, where you've got dozens of sensors in every phone, each emitting constantly emitting information, is that data is growing far faster than our ability to quickly store and analyze it. Back in 2011, it was estimated that the enterprise, on average, well, as a whole, was creating 2.0 zettabytes of data. Now, it doesn't mean most of it was stored or captured. That's just what we generated as part of our data exhaust process. And so trying to squeeze all this data into apps and then extract insights from it, it's a real nightmare. It's very difficult. So that leads us to talk about how these systems are built and understanding how that impacts identity. So this is the paradigm that has been most to analytics and computing for the past 20 years. You have a bunch of different silos, sometimes, well, often on different servers in different parts of the world. You have a budget server and a database inside there. ERP and CRM perhaps are located in Chicago. Financial reporting might be in New York. Everything you do as a business is completely siloed and segmented by department. So what that means is that it's really easy to manage identity and authorization across all of those because I know where this server sits. I know who's sitting around my server or who has access to it. I know what department they work in. And I understand what they need to do. The guys in marketing don't really need to use the financial reporting app. They don't care about that. So when you wanted to access data, it was really simple. You might have an ACL or use something like PingFed for single sign-on, and you just run the app you want, run a crystal report or whatever, do a query, and the information is right there. So this has been the world until a year or two ago. But now everything is completely changed. With the world of big data, in order to get insights, you need a lot of data. And the core concept of big data, to me, is that you have a lot of data and you want to get insights from it, and it comes from a lot of different places, high volume, high variety. So if I want to do something, for example, like just a Hadoop query, something like I want to correlate my sales to this, the clickstream analysis we did from our weblogs. I have to bring data from all these different sources into one place. That's sort of the key concept of systems like Hadoop is bring your computation to the data, which means all your data needs to be in the same place. So you dump stuff from the Salesforce API. You might dump some files out of box. You might have some internal app you've written to track clicks and so on. All these go to a big, giant cluster. And now you start doing queries on that data. But that presents a big problem because that completely destroys all the handy tricks we had to manage identity over the past 20 years. Instead of having 7 or 8 different applications, now you have one giant database. And instead of having, or really one giant cluster. And instead of being able to say, well, you sit near these other people, you're in the same department, you guys have all the same access, all that is wiped away because you're pulling in information from so many APIs, from so many different structured and unstructured sources. So you basically have a bunch of raw data on disk. And this is the state of the art. This is how things work. If you want to build correlations across disparate data sets, you have to dump all the data in one place. And nothing we've really built has prepared us for that. So applications aren't siloed anymore. Your data sort of just lives in a cloud or lives in a cluster. And the applications aren't just talking to you, a user. Applications are talking to each other. Salesforce can connect to almost anything on the planet and do something cool. And your resources in the cloud are ephemeral. I don't know what machine this is. I don't know what network it's located on. I don't know really who has access to it, especially if it's just backing an API service. So that concept of physically managing identity is gone. And the world is much more bring your own device. With my phone, I probably have 30 or 40 different apps on this, each of which has its own authorization scheme. Some sign in with Facebook, some sign in with AZA. When I walk to the enterprise and I'm checking our sales in Salesforce, the guys in IT don't really know that I'm doing that, and they don't know what I do or don't have access to. So the key thing here is that business has run off of apps for 20 years. Analytics has run off of apps for 20, 30 years. And that's not how it is anymore. Because the world of big data is not about individual applications. It's about the data itself. Getting all the ones and zeros off those disks into one place so you can query it. And that breaks a lot of models. So the real big consequences of putting all your data in one cluster is that big data queries are now inherently cross-domain. I need to build correlations across Salesforce and Marketo and my financial reporting and my web logs and so on. And not only this, but big data is really not about clever algorithms. Most of the time, it's just about throwing more data at the problem. So a lot of times I've seen in customers, they come up to me and they say, well, we bet we could get rid of 99% of the data because these are the 3 reports we run. 3 or 4 months later, they come back and they're like, I can't believe we got rid of all that data. There's this new thing we want to do that requires all this other ingestion. Storage is really cheap these days. So people just take all the data and put it in one place. And research into machine learning algorithms have often shown that having a bunch of data is more important than having a perfectly tuned algorithm. So we've got petabytes and petabytes of data just sitting there waiting to be used. And since that data is basically dumped in a raw format or pulled from an API, there's no more context. There's no more ACLs. There's no more login systems. There's really nothing that identifies who can see this data and why they can see it. In the Hadoop world, in the NoSQL world, it's just giant dumps of raw data. And that actually is a real problem because the NSA learned the really hard way over the past few months that dumping all your data into one place, such as all internet traffic ever, dumping all that data into one place and then giving some righteous and or angry people access to that just so they can do their jobs means that everybody can see data and everybody can build correlations across it, which is great. But people can see data they really shouldn't have. And we're basically trusting humans to manage their own access. And you can't really trust humans to do anything. So this is how organizations run today. If I want to manage identity across big data, what I do is I find 10 people I trust, call them the analyst group, and hope they don't do anything really, really bad. And of course, somebody always does something really bad. So how we've thought about identity needs to change in big data. All the data is in one place now. And at best, we can give a bunch of humans, we can silo people off and say you either have access to all the data or not. Which means that identity management has to start at the data layer. This is completely different than how we've done it for decades, where if you had access to this application, that's all you have access to, and we understand that. Now it's about who has access to these individual ones and zeros on the disk, because we can't extract any context of identity management from these systems that we're pulling from. So that's a big problem now. And Hadoop's been around 5 or 6 years. Actually, geez, it's probably been around longer than that now. I was one of the first users. I'd say 6 years. And so why has nobody started talking about it until January of this year? And that's because of the good old slow enterprise. It took them 5 or 6 years just to start getting these systems into production. So this conversation, which should have started 5 years ago, is starting today. And as you guys know, the enterprise has a ton of inertia. If I want to change data, if I want to change processes, if I want to modify a system, it takes years to do that. So they're still talking about how they're going to actually manage the identity. And what we're seeing happen is systems like Hadoop, Cassandra, and HBase are finally going to production at non-software companies, places like Walmart, places like Chevron, and so on. So what used to be a pet project run by some neckbeards in IT, I consider myself a neckbeard too, is now suddenly really, really important to the business. It's mission critical because the more stuff you can do with the data, the more money your business can make. And what happens is, as things move out of labs or out of beta and into production, the guys at security and IT say, hold on, now Bob in marketing has access to the same data that Jill in HR does because we just dumped it all into one place. Why hasn't anybody thought of this? And why can't we do anything about it? And you can't do anything about it today because these systems weren't built to think about security. Hadoop and NoSQL systems were built by developers for developers' problems, and those problems were speed and scalability. Security has never really entered into the conversation of any distributed system that I've seen in the past 5 years. So just like the NSA, the average enterprise is discovering that people can see either all the data or none of the data. And as a quick illustration of this, let's take a look at the state of the art, and some of this isn't even built yet, in Hadoop, which is just a file system and batch processing system. You do authentication with Kerberos if you can configure it right. It takes a lot of hope. And then authorization is really just based around users and groups. It's about as complex as Unix was in the 1980s. I can either see files and directories, or I can't. If you're running HBase, which is the Hadoop key value store, I can either see these tables, or I can't. Or in the case of managing jobs, I can either execute a job or not. There's no idea of a concept like, I can see these customers' data because I'm in sales, but I can't see my employees' data because I'm in finance, or things like that. And every box requires its own local Unix account, so it's really, really primitive. You basically can't stop people from looking at data they shouldn't see. So let's take a look at the future, and what is the concept of data DNA? So this is something that I encourage us all to think about, because even the experts in this field have really thought about identity management and big data for about 6 months now. And so if I take a look at what does it mean to manage access to data in a world where I don't know where these servers are, all the data is in one place, and it's not a bunch of apps running, it's just a bunch of algorithms running. The most important thing is that we're going to see, and we're actually starting to see this at Ping now, the concept of managing identity not just being done by IT security architects, but by developers and automation and code. That's because we have so many devices and so many apps, each talking to each other, that it kind of becomes an n-squared problem. Every app connects to every other app, and they all generate a bunch of data. And if you need to manage identity and connections across that, you can't have somebody clicking on a screen and giving individual levels of access to everything. All identity management needs to move to a shared model with APIs for developers and for security architects. And it needs to be scale-free. Identity needs to be seen as a unified platform which provisions and automates, rather than something that runs on a box somewhere that gives us some tokens. Identity needs to be pervasive, and it needs to integrate into every API and every row of data we see. And it's the other third important requirement, I think, for managing identity future is this concept of tunable visibility, where from everything from the row level to the individual bytes to a big table or to a collection of files, you can configure access based on that in a really fine-grained way so that we can ensure people can only see the data they need. As opposed to, you can use this app or you can't. You can see this file or you can't. And it has to enforce the principle of least privilege, which is the exact opposite of how things are done in the enterprise with big data today. You automatically get all the privileges if you're using Hadoop because all the data has already been dumped there, which is a horrible security practice that goes in the face of everything we've done for 40 years. So what is data DNA then? I see it as a way to record the history and understand the context of every piece of data in the system. It's about understanding who can see the data and, just as importantly, why they can see the data. And so there's sort of three key things you have to do if you're rolling out this data DNA system. You have to minimize the surface area to be protected. And this is actually a little opposite of how we've done things in the past. If you can control, if you've got trillions of rows of data in your system, and you can control who sees every single row, which is what you're going to need to do, suddenly just that amount of information alone in the actual control system is a big data problem itself. You know, it could take bytes of every row to access who can see information what. So you have to think really carefully. Do I really need row-level security? Or can I index these rows a certain way and provide people access based on that? Or can I build some sort of highly targeted application that only lets people see certain pieces of data? And you have to now come up with a trade-off between speed, storage, and coverage. If you've got trillions of rows in your system and you have to check every single row to see who can see it and who can't, you're going to have the best row-level security on the planet, but it might take a few years to get your data. That's just not viable. So this is a conscious decision that we as developers and as IT architects now have to make. And we need to segregate not by application, but by use cases. What are you doing with this data, and what knowledge does that set of algorithms require, instead of here's all the data, play with it as you will. And finally, we need to build systems that are self-monitoring. And this is a pretty new concept in identity as well. But when you're managing trillions of rows of data and petabytes of data, you can't be thumbing through logs to see what's going on. The system has to be smart enough to say, hey, we see that you have access to this data, but you've never really used it. Maybe you don't really need that, and we can clean up the system that way. Or you keep trying to run this query, and it's giving you incomplete results. Maybe you don't have access to data that you need. We should review that policy. So a system has to be smart enough to manage itself, because as humans, we just can't do that anymore. The data is multiplying far too fast across tens of thousands of servers. And we can't pull up a little UI and thumb through that information to see who needs what. So that's the future. That's going to take a long time to build. And so what do we do? What's going on right now? What's the state of the art of identity management in big data? And it's pretty fractured. Some folks are coming to it from an API perspective, which solves a little bit of the problem. And there's a lot of companies out there who help manage authorization and access and security across APIs, which is good, because as APIs keep talking to each other, you need a universal way to keep that information from exploding and to keep people from accessing the wrong stuff. But with the big brute force platforms, these big bulk processing platforms like Hadoop that are building the core of a lot of companies' big data strategies, vendors like Cloudera and Hortonworks aren't even resourced to do anything more than submit open patches to projects like, I think it's called Apache Knox, until 2014. They're so busy trying to move stuff into production. And like we said earlier, they're just now hitting that problem of, oh crap, we're in production. Who can actually see this data? That this isn't on the roadmap for folks like Cloudera and Hortonworks. So in the meantime, we're going to see more things happen like they did at the NSA, where because you need to see all the data to do your job, you're going to see data that you really shouldn't. But for the entrepreneurial-minded here, this is a huge opportunity, because we basically have zero data security now in big data. And if big data is going to be pervasive and but inform every part of our lives, that means that we need to see an entire big data security industry. And there's a few startups and a few vendors are talking about that, but building a security industry from scratch is a multi-billion-dollar opportunity, and it's going to be really interesting to see who pops up in the next few months and years to go ahead and build that. Any quick questions? Cool. Well, thank you very much.